we're going to talk about system variables today. We talked about variables last week, and of course, we worked on an exercise to kind of reinforce how variables work. And so we're going to look at some more variables today. I'm going to put a link to these notes in the voice channel if you guys want to open those up. And we're going to kind of review a few things here. This is going to be, for tonight, this is just going to be a kind of a basic introduction to these concepts, and you guys will be able to kind of play around with these and add some interesting effects and interactivity to your self-portrait projects. But we're not going to cover everything that you'll probably need to finish the assignment for this week. We'll do that on Wednesday. Just so you know, if you are working on the assignment that's due next week, and you're confused about anything, that's because we are not going to quite cover everything. But we'll cover enough that you guys should be able to get started. So I'm gonna open up an editor page as well. So I'm gonna be going over some stuff, and I want to be able to demo it over in the P5 editor. I'm gonna open up my variables, one of my variable sketches. Let's see. Okay, so this is the self-portrait that I was working on last week with my X and Y variables. This is the one where I didn't add in the size variables. So this will be a good one to start out with. I can always go back to the size one later if I need to. So what I'm going to do is just duplicate this so I don't overwrite the original. And I'll just use this to demonstrate system variables. So I'll call this self-portrait interactive 1. I'll probably make multiple ones of these. So I'm just going to update these notes here. So I'll call this interactive self-portrait. I'll just put version 1 here because I'm probably going to make more. Put my name and the date. Okay. And I may also want to just have a blank window open for some of the stuff that I'm going to demo. So I'm going to add in another blank window here. I'll just call this system variables in case I want to demo anything else here. 2023, this is 210. Okay, so let's get into it. So system variables, so these are variables that P5 creates for us, and they can be very useful for controlling various aspects of our designs and adding interactivity. And it's also good to know about these because as we start to create our own variables, it's good to know about which variables already exist. So that's something that we want to cover. So we're going to quickly review setup and draw. We've done this a few times. It's always good to kind of go over this, but we're going to just quickly review this again. So remember that setup is called once when our program starts, and it does things that we only want to happen once, like let's look at the default here, like create the canvas. So when we call setup at the beginning of our program, so for example, I can run the program by hitting play here. It just creates that canvas here, and then the draw function is what's actually drawing the background down here. So that setup only happens once. I can also demonstrate by, let's say in console.log setup. Notice that we just see setup happens once in the console down here. Okay, as opposed to if I say console.log draw. Now, what's going to happen is you're going to see, so the console actually puts these together. So we're just seeing this number increase, but that's how many times it's logging draw. If I want to see this, you know, going down the page, I can add a value that's changing in here. This is actually a variable that we'll talk about tonight. But there you can see how many times it's logging draw. So the draw function is going over and over again, whereas the setup function just runs once at the very beginning of the program. So that's setup and draw. I just want to kind of go over those again, just review that, because now that we're starting to add interactivity, this is when these two functions really come into play. So one example that I can show you. So here we have like a very simple animation. And one of the things that you might notice is that there's this weird sort of like bleeding of color that's going across the screen because I'm not drawing a background in this example. And if I bring this background back in, now what we see is just the circle. Okay, so the background is constantly drawing on top of what was drawn the previous frame. And that gives us this illusion of motion. It makes us able to do interaction and animation. So if we take this background out again, so I'm just using the comment to remove it so that the compiler ignores that. And if I preview this again, so a couple things. So notice that you see this pink square that we didn't see before. That's because that's being drawn in setup. So you can actually use setup to draw. And sometimes if I'm making a program that I just want to like create a design once and not, worry about it later, I'll just put everything in setup and it'll just draw it once and then I'll be done. But most of the time when we're using code in P5, we want to create something that's changing, dynamic, interactive, or animated. And so we're going to use the draw function. So we can see that this rectangle just gets drawn once, but then it gets covered up by the circle because once it gets drawn, it's not getting redrawn. Whereas our circle is constantly getting drawn over and over and over again. That's also why we see the edge of the circle kind of like bleeding out over. Let's see if we change the color a little bit. Let's change the fill to blue. And let's turn off the stroke. So now we just get this solid color because that circle just keeps filling in. Okay, what if we change the rate of animation a little bit? I'm just going to multiply this by 5. That's still filling in. What if I do by 10? So we're still filling in. Maybe I should try changing the frame rate here. Let's do the frame rate as like, no, that's going to be way too slow. Let's do 12. Okay, so now we can see, or we're seeing basically the same thing. I guess taking out the stroke kind of obscures the shape of the circle. Let's take the stroke back in for just a second. So yeah, now we're seeing each circle being drawn. It's still creating this kind of like edge, but now I think if I increase the frame count, there we go. Now we can see the separation of the circles that are being drawn. So let's do it one more time, then we'll move on. Okay, so now you can actually see the separate circles. Hopefully that makes it a little bit more clear what's happening is that we're drawing a new circle. I slowed down the frame rate a little bit so they're not updating as often, but we're drawing a new circle each time we draw the frame. But when we put the background in, we get this feeling of motion or animation because we're covering up what was there before. So that's really all that's happening. That's like the big magic with animation and P5 and how these programs work is that we're just drawing a circle in a lot of different places over time. But since we're covering the background, we're sort of erasing what was drawn before. It gives us this illusion that we have motion on the screen. Okay, so one thing that we are going to run into in this lesson and in the next few lessons that we're going to be working on is this idea of scope. So scope refers to where your variables exist inside of a program. And we can use a quick example to show where this will become an issue. So let's say I have an ellipse and it's at 50, 50, 50. And so there's my ellipse. Let's say I want to move it across the screen. So as we learned last week, if I want to move something, I need to use variables. So let's make a variable called x and set that to 50. And then let's increase x. Let's say x plus equals 5 every frame. So my ellipse is still moving. And the reason for that is a little tricky, but basically what's happening is because my x value, let me get my, there we go. So my x value starts here. Oh, I forgot to actually put x in. So this won't change anything, but let's just do that here. So I'm declaring x uh, up here, and then I'm using x right here. So x is still 50. And then I'm adding 5 to x. So x becomes 55. And so you would think that when we go back to the beginning of the draw loop on the next frame, and then we come through, x will now be 55, and our circle will be 5 pixels over. But because we're redeclaring x right here, that means that x goes back to 50 because we're declaring it again. So this is something that you might run into as a new programmer, where we run into this issue of declaring a variable versus initializing or setting the value of a variable. So all we have to do to fix this is move our variable declaration up to the top of the program. Now we'll see that we're off and running. Our x works now. Let's do 1, so it's a little bit slower. So there's a couple things to note here. So one is I can still reset x. So if I still said x equals 50 here, I would still get this same issue. So even though I'm not using var here, I can still reset x, and so I would still come up with the same problem. Another thing that's useful with using a variable here is that now x exists inside of setup and draw. So let's say I initialized x by itself, and then in setup I say x equals 50. So now it still works the same way because I have this variable x, and then I set it according when I run the setup, and then by the time I get down here to draw, it's going to know where x is. But if I forget to do that, I get an error. Okay, let's see if I have an error down here. So it's actually not the error I expected to see. Oh, because x is defined, but it's undefined. So yeah, so we're not getting x here because I've never actually set x to a value. So then you might say, well, I need to say variable x equals 50 here. But then we're back at the same issue. This variable x has overwritten this variable x. So even though I started with x and I set it to 50, if I redeclare x, that new x is overwriting the original x. So that's another thing that we have to be careful of. Once we declare x once, we don't want to redeclare it down here. Okay, so this is referred to as variable scope. If I create a variable up here outside of my functions, then it exists inside of my functions. But if I create a variable inside of my functions, it takes precedence inside that function, and it only works inside of that function. So another example, another issue that you might run into, let's say I declare variable x inside of setup. Now I still get the same issue, and in fact now I'm getting an actually useful error. X is not defined because x is no longer global. I declared x inside of setup. X stops existing the moment I leave the setup function. And so now when I go to draw, it's never heard of x because because that x only existed inside of setup. So that's why we tend to put our variables at the top of a program. There are cases where we want to put variables inside of a function if we only want to use it inside that function, or if we just want to use it once and have it disappear by the end of the function. But most of the time when we're writing code, we'll see our variables at the top and then our functions will come later. So that's just a little note on scope. And you'll start to see examples of that as you add variables into your code. Okay, so let's talk about some of the static system variables that P5 gives us. So these are things that P5 creates at the beginning of the program, and they don't change during the program. So that's why they're static. An example of a static system variable is the width and the height of our canvas. So I'll show you an example here. If I, at the top of my program, say console.log width and height, notice that P5 turns those values pink because it knows what they are. But we're going to get an error here. So I'll open the console and run this. And I'm going to get this error, width is not defined. So the reason that width is not defined at this point is because we haven't created the canvas. When we create the canvas, P5 sets the width value according to whatever we want it to be. So if I move this little log statement down here after I create the canvas and run this again, I'm getting an error. Let's comment out this code for just a second. Okay. So there we go. So there's my width and my height. So the width just tells me in pixels how wide the canvas is, and the height tells me in pixels how tall the canvas is. And I know what these values are because I set them when I create the canvas. So if I change the height of my canvas to 600, then those values update. And this is really useful for a lot of reasons. If we're designing a program, we want to be able to know the size of the window that we're in so we can make determinations about where to put things. So for example, if I want my ellipse to start in the middle of the canvas, I could look at the number and say, okay, well, 400 divided by 2 is 200. So if I set x to 200, that will put my ellipse in the middle of the canvas. Okay, so that worked fine. But what if I change the size of my canvas to 300? Now it's not really in the middle anymore. So using our variables, we can do math. We can have the program do math for us rather than having to do it on our own. So instead of using 200 here, I can use the value, the number width, which is going to change whenever I change the width, and I can just divide that by 2. And so now P5 is going to do that math for me instead of me having to do it myself. And so now I get the circle right in the middle of the canvas. And if I change the width back to 400, the circle goes with me because that variable changes. It changes according to the parameters that I start with. If I set the canvas width to 500, now we still get this, we're still in the middle, at least on X, not on Y, because Y is hard-coded. But on X, we're getting whatever that width value is divided by 2. So if we want to do the same thing with Y, I can set Y up here, and now I can say Y equals height over 2, and I can add Y in here. And there we go. Now my circle will always be exactly in the middle of my canvas. So, if I change it back to 400, oops, by 400, the circle is going to be in the middle. So centering something is one very useful way of using the width and height, but there's a lot of other things that we're going to use it for, especially when we start to do animation. We want to know, what the dimensions of our canvas are. But you could set things, to the side. Let's say if I wanted, the X to start all the way on the right, I could just set it to width. And so now we can see the circle all the way over here on the right side at the width of the canvas. So those variables are very useful for understanding the dimensions of our canvas, which may change, and then updating our code to match that. So, excuse me. Speaking of, the dimensions of our canvas, those can change, obviously. I'm trying to find the part. I don't actually, maybe I don't mention this. Okay, I don't mention this, but I'm going to show it anyway. Um, as you guys know, when we load a website, it's always going to be on a different device. It might be on a desktop or a laptop, it might be on a phone, and those devices are always going to have different resolutions. So if we want to know exactly what the resolution of our context is, the context where somebody's viewing our program, we can use window width. This is another static variable that P5 creates for us that tells us the width of the context where our project is. So if I run this again, you'll see that our canvas fills the preview window regardless of what the size of that preview window is. So if I drag the preview window over here and run it again, it's going to fill up that preview window. And if I drag it all the way over here and then run that, you can see now it's narrowing the canvas to match that preview window. So the window width and the window height is really useful if you want your project to take up whatever space is available. And then once you've done that, the width and the height values still work exactly the same. So you can still find the center or the top or the bottom, left or right of your canvas. So let's put this back at 400 by 600 for a second. And then one thing I want to show you, we've already kind of seen this, but just to review, if I take this X out and put it back up here, I'm going to get an error. So just remember, if you see that, you can't use a lot of these P5 things outside of the P5 functions. So the width only gets defined once we're inside the setup. If we try to set X to the width outside of the setup, we get an error because width hasn't been created yet. So that's another issue with scope. I need to declare these x and y values up here so that they can be assigned here and then used down here. If I take out these x and y's here and then I declare them inside setup, I get this error because again, these x and y, they only exist inside this function setup because I've used the variable keyword to declare them. So I'm saying these exist, but I'm inside of this setup function. And so when the setup function is done, those variables disappear. So for this to work correctly, I need to declare my variables globally. I need to assign them in the setup function, and I need to use them down here in the draw function. Okay, let me put a couple comments in here. Let me know if you guys have any questions. So these are global variable declarations. We're saying that the variables exist, and then assigning values using width and height once they're created by create canvas. And then finally down here, using X and Y for our position. Okay, so this is just position, but width and height variables work the same way. Okay, so let's continue. So those are static system variables. So they're ones that always stay the same. The width and height are kind of the main ones. And once we create our canvas, we've determined the width and height for the rest of that program until we write it in a different way. There are also dynamic system variables. These are variables that change over time, and these are the variables that are going to be most useful for us to create interaction. These variables are typically used to capture information about the scene. Things like if the user is pressing a key on the keyboard, if I'm moving the mouse, there's how long the scene has been running for. I can use the frame count. So there's a few of these that are really useful. We can look at the P5 reference for just a second, and I'll show you where you can find these. So a lot of them are under events. If I go to events, you can see all of the values that are related to the mouse. So anything that does not have parentheses at the end is a variable. It just has one piece of data like a number or a Boolean or a string. Anything that has parentheses at the end is a function like setup or draw that we need to write into the code as a new function. Let's see, where are the other variables? So environment, there's a lot of variables related to the environment. That's where we're going to find the frame count. That's the number of frames that have been drawn as the program is run. The delta time, that's how much time has passed since you started the program. Um, we see the window width and window height, which we just used. We see width and height, which we used as well. There are also functions here like window resize. This will trigger if your user resizes the window, and you could take that into account in your design. So yeah, environment and events are where you're going to find most of these system variables. Okay, so let's use our mouse X and mouse Y. So in here, what I'm going to do, I have this X and Y, and they start at the width and height, but let's say I wanted them to move. I could say X equals mouse X and Y equals mouse Y. So now what's going to happen is as I move the mouse, my circle follows the mouse. So mouse X is a value that P5 makes for us. We know that because it's a variable that we didn't create. There's no point at which I said variable mouse X. So anytime I have a variable like width or height or mouse X that I didn't make myself, that means that the P5 library made it for me. So when I set X to mouse X, that means the X value of the circle is changing as I move the mouse. So I'm moving the mouse around on my computer and we see the circle follow. Same thing with the Y value. This happens to track really well with the circle because, of course, my cursor is in the same position on the canvas as the circle that I'm drawing. But it doesn't have to be position. For example, I could just put mouse X directly into the size value, and now my circle gets bigger as I move to the right because that number is changing. If I move up and down, it doesn't really matter because I am not tracking the Y, but I could do that if I want. I could put another value in here and say mouse Y here. And now if I go up, it flattens out. If I go down, it gets bigger. And then I could also reverse these. They don't have to be relative to their actual, parameters. So I could swap mouse X and mouse Y, and now as I move left and right, my circle gets bigger, gets taller or shorter. And if I go up to down, my circle gets wider or more narrow. So there's lots of different ways I can kind of like crisscross these inputs to create some kind of like interesting results. Let's put another circle down here and I'll map these correctly. I'll say mouse X, mouse Y. And so now we'll kind of see the inverse results happening. So I can kind of do some funny stuff with this. So you can see there's a lot of different things that we can do with these basic few variables. So now we know where the user has the mouse, and that gives us the ability to do lots of different things, like determine if the user is clicking on something or interacting with something, and then change our design to update to match what we want that interaction to be. Okay, so let's keep going. There's another value that we can use called pmouse x and pmouse y. Um, this one will be a little bit trickier to demonstrate. Let me just take some of this stuff out for a second. But what I can do is say, let's create a line. So let's create a variable, and I'm going to call this delta x. Delta is just kind of fancy word that we use in programming a lot that means change. It comes from Greek. So delta x is going to be the mouse x minus the p mouse x. So p mouse x, p just means previous. So there's basically like the current point and the most recent point. So then I'm going to have a variable delta y and set that to mouse y minus p mouse y. And so now I can use this to map onto something. So I could say ellipse. We can actually use the rest of the code actually. So let's bring this back. And what we can do now is let's just draw one ellipse. And instead of using mouse X and mouse Y for the size, let's use delta X, delta Y. And so now notice if I move my mouse very slowly, you don't really see very much because the value is very small. But if I move my mouse very quickly, suddenly we see a much larger circle. So the wider the distance between those 2 points, the more the higher that value is going to be. Let's add a little bit to there so there's like a default. So let's add 50 as the default. So I'm just going to say plus 50 on both. So now we have our regular 50, and if I move it around, it gets a little bit bigger. And if I, move it up and down, although sometimes it's getting smaller because I am taking. So if I go to the left, it'll get smaller. If I go to the right, it'll get bigger. So let's actually one thing that we can do is we can make something the absolute value just by putting ABS. Absolute value basically just means that if something's negative, we take the number and take out the negative sign. So it's how far it is from 0. So let's take the absolute value of this so that we can see how fast it's moving, but not necessarily the directionality. Okay, so that's kind of fun. Um, let's do one more thing real quick with this. I'm just going to draw a line between mouse X, mouse Y, and P mouse X, P mouse Y. And I'm not going to draw the background, and you'll see why in a second. Oh, well, I need some background. Say background 220 up here. And let's take out my ellipse for a second. Okay, so now you can see I'm just drawing a line. So it's creating a line between the current position of my mouse and the last position of my mouse. And so, from here I could start to make like a cool drawing application like Photoshop or Procreate or something like that. Obviously, there's a lot I would need to add, but you can see how you could start to get, the basics of creating a drawing application just from like this really simple data, where the mouse is and where it was previously, and just drawing a little line. So I can kind of create some like little, cubist portraits with this. And I could add some events to, save a picture or something like that. I could create something cool that way. Okay, so that's P mouse X and P mouse Y. Let's take this out for now. And let's see. I think we only have one. Yeah, the frame count is the last one we're going to look at. The frame count just tells us how long the program is going for. So for this one, I'm just going to take my ellipse and I'm just going to throw the frame count in here. And so what you're going to see is that the ellipse just gets bigger and bigger and bigger the longer the program runs, because that value is mapping onto the size of the ellipse. So we're really just taking a number that's getting bigger because it just tells us how many times we've drawn the canvas, but we're using it in a different context. We're taking that number and we're throwing it into this size. And so that gives us this kind of cool effect where we see this kind of like growing circle. We're going to look at ways to kind of control these animations a little bit more purposefully on Wednesday and in later lessons as we kind of learn more about interaction and animation. But this is really just kind of introducing these sort of like basic ideas of the types of information that we can capture using P5 or really any program. So the things that we know about are, the user, where the mouse is, how much time has elapsed. There's other things that we'll look at soon, like if the user is clicking, if they're touching the keyboard, different things like that. But for now, this is what we're just going to get started with. So let's go back and look at the assignment for this week for a second. I'm going to go back to week 4. And so for this week, we're going to make an interactive self-portrait. And I'm not expecting this to be like some incredible, amazing, dynamic piece of interactive art. But what I want you to do is just think about something that you could interact with in your self-portrait and then just use the variables to create that interaction. So you can interact with the size, the position, or the color. This part, use the map function. That's something that we're going to cover on Wednesday. So don't worry about that quite yet. You can get started just looking at some basic interactions, tonight, just using the system variables. So one thing, I didn't actually show color, so let's show that real quick. So let's put in, um, let's just do this real quick. So for the fill, I'm just going to also use the frame count. So just to show that you can use, see as the color gets bigger, as the number gets bigger, we go from 0, which is black, to 255, which is white. We could also use it as a color. So we could say frame count 0, 0. And so what we'll see is it gets more and more red over time because that red value is growing. And you can also do that with the mouse X. So, I could put in mouse X or mouse Y for the blue value. So you can see the colors shifting as I move across the canvas. So that's pretty exciting. So when it comes to the self-portrait, really, I would recommend keeping things simple. Find something that you can see in your self-portrait that you can animate, that you can move around, that would be kind of fun, that might be kind of interesting. It doesn't have to be super complex. So one thing that you can do, of course, is look at previous student work. There's some examples of self-portraits here. This is a pretty good one where you can see this student, excuse me, created uh, excuse me, just a second. Sorry. You can see the student created this like alien self-portrait where they're really just moving this like big ice cream cone back and forth, and then the mouth opens as well. So, there's just a couple values that are changing here, but he created this really interesting, uh, you know, um, interaction where we're kind of like, oh, if we move our mouse, we can, make the alien eat this ice cream. So I'm going to just take a second to look at my self-portrait and look at a couple places where I could add interaction really easily. And then I'll leave you guys to work on your own project. So here's my self-portrait. I've got a couple different things that I could pretty easily update using interactivity. So actually, I haven't done this before, but last week when I was animating stuff, we had that moment where it looked kind of like Pinocchio because the nose was stuck and it was moving around. So let's just do that real quick. So let's say I want to do Pinocchio. I'll just find the nose. It's really simple. The nose is just the X, Y, position of the character, and then all I have to do really is replace the second part of this line with mouse X, mouse Y. It's really simple. So now I can create Pinocchio, so I can start with the regular nose, and then I can, make the nose longer. So that's, super easy, really basic thing I can do. Another thing that we saw in the example is the mouth was moving open. That's really just changing the height of that arc. So let's do that as well. So I have the arc here, and the height of the arc is this number 40 right here. So what I could do is a little math here, and this is something that I'll cover a lot more in detail on Wednesday, but if I just put in mouse X, or let's say mouse Y for this one. So if I just put that in, it's going to look a little goofy, right? Because the eyes are going from really, really big to really, really small, and it's not really related to where the mouse is. So let's look at a couple levels of sophistication here. So um, one thing I could do is I could just take the mouse Y, but then I could just like divide it by a certain amount so that it's not too crazy. So I could say like variable, let's call this I height, and I could say mouse Y, and I could just say like, divided by, I don't know, 10 or something like that, just to make it a little less nuts. And so now we get something a little bit more reasonable. As it goes up, it goes down, and then as I pull it down, it kind of goes normal. So that's pretty good. That's not too crazy. Um, what else could I do with this? I could basically make it so if it's 0, then it just completely disappears. I don't really want that, so I could add a little bit to the top. I could say 10 plus this value, so that way it never goes less than 10. So that's pretty useful. I can just do a little bit of math, save this in a little variable, and then put it in right here to control this a little bit better. As I mentioned, we're going to look at better ways to do this on Wednesday, but this is just kind of an example. I can use a little bit of math here to make this look a little more normal. And let's see, what else could I do with this? If I go up, it goes like that. I could also use the change. That's another thing that I kind of already showed. So let's leave that there. I could say variable I height equals, let's say the absolute value of Y, that's where the nose starts, minus mouse Y. So however far away the nose gets, the eyes will get bigger. That's another thing I can do with some pretty basic math to kind of match these so that no matter which direction I'm going in, the eyes will get larger if I move the mouse away. And then I can do the same things here. I can say, well, I don't want it to go lower than 10, so I'll just add 10 there. So even if I'm really close, it goes only down to 10. I could divide this mouse Y a little bit, like maybe divide that by 2 to make it a little less dramatic. Maybe I need to divide it by 4. That seems to make it more dramatic. Oh, because Y is starting up here and then it's just getting bigger and bigger and bigger. Okay, that didn't really work, but that's okay. That's part of the experimentation process. Okay, anyway, I think this is good enough. I'm going to save this, and I'll put both of these examples into the voice channel for you guys to take a look at. Of course, there's a lot of examples in that student examples page that I showed you guys a second ago, so I would go check that out if you're like, I have no idea what to do. But you guys can just play around with these. As I mentioned, Wednesday we'll go over the map function, which is a much more controlled method of using these values and getting a specific output. So we'll look at how to do that on Wednesday. But yeah, for now, we've got a good amount of time left in class. I would just like play around with these variables and just see where, if I just add, just go to a random part of your self-portrait and just say, okay, what if I put, mouse X here? What is that going to look like? Okay, that's kind of cool or not, whatever, I can, start over. Or what if I put frame count right here? Okay, that's kind of interesting, but then it just kind of turns into that and it's not that interesting anymore. So let's let's take that out. So you can just like put those values in different places and just see what happens. And then, kind of keep stuff that looks cool or get rid of stuff that doesn't work or, whatever works. Okay, so I'm gonna take this part out too because we don't need that anymore. Okay, I'm gonna stop the recording here.